Hello. In this video, we're going to let f of x equal 6 divided by x minus 3 and g of x equal 1 divided by x. We want to find the compositions f composed of g of x and its domain and g composed of f of x and its domain. Okay, let's start with A. We have f composed of g of x. Remember, this simply means f of whatever g of x is. So g of x. So this is going to give us, working from the inside out, we replace the g of x with what it is. In this case, 1 over x. So this is really just asking us to go to the f function and replace all x values with 1 over x. So we have 6 divided by 1 over x minus 3. Then we need to simplify this. To simplify this, what we mean by this is to get rid of any complex fractions. And what we have is a complex fraction because there's a fraction in the denominator. And to get rid of there's a couple of different ways. Well, first of all, you can combine the denominator into a single term, then use 6 divided by the denominator, which means you 6 times the reciprocal of the denominator and go from there. I don't like to do that because honestly, most of the time that just makes it more difficult than you need to. Okay, so look at all the individual terms that you see here. You see 6, you see 1 over x, and you see 3. Forget the signs. Signs don't matter right now. Notice that there's only one fraction here, and its denominator is x. So the LCD between all three terms here, the least common denominator between all three terms, is x. So what I'm going to do is I'm going to multiply both the numerator and denominator by x. And that means I distribute the x into both the numerator and denominator. Doing so will give me 6x divided by, now notice that x times 1 over x, they're reciprocals of each other. So that just gives me 1 minus 3 times x is just 3x. And notice that in just one little step here, we've simplified this, making this 6x divided by 1 minus 3x. So our answer for f composed of g of x is 6x divided by 1 minus 3x. Fantastic. Again, I'll look at the domains here in a second. If you look at B, we have g composed of f of x. And what we get from this is that this means g of the f of x function. And again, working from the inside out, what this means is g of whatever f of x is, which is 6 divided by x minus 3. And so all we're really asking here is, what is g of 6 divided by x minus 3? So in your g function, all of the x's are replaced with 6 divided by x minus 3. So this is going to give me 1 over 6 over x minus 3. Now, you can do this in a couple different ways, and the way that I just showed you can be done here. So let's look at it this way. There's a term in the numerator, which is just 1, and there's a term in the denominator, making that 6 divided by x minus 3. Now between these two terms, there's only one denominator, which means x minus 3 is the LCD. So I'm going to multiply both the numerator and denominator by x minus 3. Notice the x minus 3's cancel each other in the denominator, and then you distribute the 1 right there, and that's going to make it x minus 3 all over 6. And most people are going to leave it this way, but I want you to realize that you can actually write this as 1/6 x minus 3 over 6, which simplifies to 1/2, which means that g composed of f of x is 1/6 x minus 1/2. Now we want to look at the domains. Look at f composed of g of x. Okay, well, the second function that's listed is g. So what's the domain for g? Well, if you notice, g is a rational function with a denominator, which means that denominator cannot equal 0. And then you would solve that inequality. Notice it's already solved for x, so that just means that x cannot be 0. Now we look at the answer, and then we look at the denominator of the answer because we have a rational function, 1 minus 3x. And its denominator is 1 minus 3x, which means that can't equal 0. Solve for x by subtracting 1 divided by negative 3 means x is not equal to 1/3. Now notice that on the number line, I can't have 0 and I can't have 1/3. But I can have everything to the left of 0, excluding 0. I can have everything between 0 and 1/3, excluding 0 and 1/3. And I can have everything to the right of 1/3, excluding the 1/3. So this means that by having two different numbers that I cannot use, this actually breaks the number line up into 3 separate regions. So the actual domain here for f composed of g of x is negative infinity to 0, union 0 to 1/3, union 1/3 to infinity. Pardon the crazy writing there. Anyway, this is the domain for A. Now let's look at the domain for B, which means we need to look at the second function that's listed here, which again is f. So if I look at the f function, again it's a rational function, so we need to set the denominator x minus 3 not equal to 0. Solve it by adding 3, so x is not equal to positive 3. Now that's for f. Look at the answer here, 1/6 x minus 1/2. This is just a polynomial function. So for this portion, it's everything that I can use, negative infinity to infinity. So there's nothing that x cannot be from the answer, but we did get that x could not be 3 from the f function. Therefore, notice that on the number line, there's only one number that I cannot use, and that's 3. But I can use everything to the left of 3 and everything to the right of 3. I just can't use 3. So the actual domain for this function is negative infinity to 3, union 3 to infinity. Notice that we really can see that f composed of g is not the same thing as g composed of f. In fact, f composed of g is again another rational function, and g composed of f looks like a polynomial function. But this polynomial function means it's a line, but it's a line where you can't use 3 for the x value. Even though if you plug it in here, you're fine, but plugging it into the f function means that you're dividing by 0. Alrighty, well, have fun. I'll see you in the next video.